Hello and welcome to the Tuesday lecture for week 3. Pay particular attention to the problems that I'm working today. I worked a lot of these in class last week, but I am working some that I think that you will see on your next test. The topics are from chapter 7 from the functions, and we looked at some of these last week, but I'm going to go through some things that we didn't go over that you should know, and then some things that you will remember from the last in-class class we had last week. All right. Let's take a look at this one. We worked some of these, solving an inequality and graphing the equation. I've got 4x plus 7 is greater than 27. So 4x plus 7 is greater than 27. You have to get used to my pen. Let me make that a 7. So the first thing I would do here is subtract 7 from both sides. And I will get 4x is greater than 20. And then what are we going to do? We're going to divide both sides by 4. I'm going to write over that. My 4's will cancel out, giving me x is greater than 20 divided by 4, so x is greater than 5. So if I were to graph this, I've just got a blank number line down here. Let's call this, I don't know, 3, 4, 5, 6, 7, 8, 9. X is greater than 5, so I'm going to make a circle right there. It won't be a closed-in one. And then my line, I'm going to kind of make it out this way. Put me a nice arrow on it. So it would be everything is greater than 5, but I do not make my dot solid because it's a greater than, not a greater than or equal to. Let's look at another one. Solve the following inequality and graph the equation. Negative 3x is greater than or equal to negative 21. Negative 3x is greater than or equal to negative 21. You better be telling yourself at this point, I'm going to be dividing by a negative number, so I've got to change the direction of the sign. So I'm going to divide by negative 3. I still have my x, but my greater than or equal to is now less than or equal to. I have to change the direction when I multiply or divide by a negative number. Negative 21 divided by negative 3, of course, is a positive 7. So my final answer is x is less than or equal to 7. Let's just pick some random numbers here. 3, 4, 5, 6, 7, 8, 9. But x is less than or equal to 7, so I'm going to make that a solid dot because it's a less than or equal to, and of course it's going to be going to the left. Let me just make this. You got to understand I'm using my magic pen here, so my writing on the board may be a little bit better than that. But x is less than or equal to 7, so includes the 7. I color in that dot, and then everything to the left of that. Let's look at another one. On this one now, it's negative x is less than 2x plus 9. Let's come down here, and this is one of those where I'm going to keep my variables positive if I can. And I will. It'll cause me to have to do an extra manipulation. Negative x is less than 2x plus 9. I'm going to add x to both sides. This is me doing this. Add x to both sides. I get 0 is less than 3x plus 9. I'm going to subtract 9 from both sides. If I just subtract a number, I don't change the direction. So I've got negative 9 is less than 3x. Now I'm going to divide by 3. Those will cancel out. Negative 9 divided by 3 is negative 3. Let me come over here. Negative 3 is less than x. Remember what I said about this. You want to remember x needs to be on the left, but think of that as a Pac-Man, okay? He's eating the x. So I'm going to put the x on the left. Now the Pac-Man is still eating the x. X is greater than negative 3. So let's graph this. I'm going to put, I don't know, 0. There will be my 0, negative 1, negative 2, negative 3. This would be positive 1, positive 2, positive 3. But x is greater than negative 3. So it'll be an open circle there since it's not greater than or equal to. And my arrow will be going to the right. X is greater than negative 3. Pretty cool. You say, well, Brent, could I have just gone ahead and subtracted 2x from both sides? You could have. Look what happens. Subtract 2x. Some of you might think this is easier. Subtract 2x. And I get negative 3x is less than 9. Divide by negative 3. Divide by negative 3. And remember, when I divide by a negative number, I'm going to get x is greater than, I change the direction of the sign, negative 3. I get the same answer. I just like to keep my variables positive. That's all. Let's look at another one. Plotting points. I just want you to remember, we did this the other day. Plot the point negative 1, 3. Remember, my x value is first. If it's negative, I go left. If it's positive, I go right. My y value is second. If it's negative, I go down. If it's positive, I go up. So the point negative 1, 3. Here's my origin, so I go to the left 1 and up 3, and that'll be the point right there. So there is the point, negative 1, 3. I'm going to draw a line over there and pull an arrow at it. Bazinga. Just remember that. And have some examples, and there's plenty of examples in the book there on those too. Just don't get mixed up. Let's look at another one, graphing equations. Now, notice this. Sometimes students get mixed up. This is one of those where you should pay particular attention. Graph for x is between negative 3 and positive 3. Well, what I do here is I'm going to set this up. I'll make myself x and a y. And plug in, I'm going to plug in a negative 3, a negative 2, a negative 1, a 0, a 1, a 2, and a 3. I'm going to plug those in. Just plug and chug for each one of these. In other words, negative 3, what does that give me? All right, you would say y equals negative 2 times negative 3 plus 4. Negative 2 times negative 3 is a positive 6 plus 4 is 10. Now, I'm not going to do every one of these. Let me see if I can make a better looking 10. So my y for negative 3 would be 10. So I can find that point on here. I can pretend that I can find it because it's going to be off the graph. Sometimes I'll lose my pen when doing this. All right. Oh, I didn't mean to do that. Negative 3, 10. So it would actually be up here somewhere. I'm going to go up there and put a point. You'll follow me in just a second. Negative 2. Negative 2 times negative 2 is positive 4, makes it an 8. So, okay, so at negative 2, I have a positive 8. This is going to be about right there. At negative 1 times negative 2 is positive 2. 2 plus 4 is 6. So I'm going to have a point right there. 0 times negative 2 is 0, plus 4 is 4, so there is another point. 1 times negative 2 is negative 2, plus 4 is a positive 2, so I have a point right there. 3 times negative 2 is negative 6, plus 4 is negative 2. Wait a minute, I need to do the 2, don't I? 2 times negative 2 is negative 4. That makes it a 0 right there at positive 2. So there that is. Then negative 3 times, positive 3. Let's write these in. Negative 1 times negative 2 is 2, plus 4 is 6. 0 times negative 2 is 0, plus 4 is 4. 1 times negative 2 is negative 2, plus 4 is a positive 2. 2 times negative 2 is negative 4, plus 4 is 0. Finally, 3 times negative 2 is negative 6, plus 4 is negative 2. So I'll get this line, and I'm going to see if I can insert a line here or something. Let's see. Shape, if it'll let me draw a line. I'm going to try this. It should be a line like that. I'm pretty close. Come on, Brent. There we go. And it's, it's not perfect, but you can see it's a line. And if some of you remember from your algebra days, you can tell this line is in y equals mx plus b form. 4 right there, the plus 4 is the y-intercept, and sure enough, that's where it hits the y-axis. The negative 2 is the slope, so I go down 2 over 1. And that slope is going downward in direction. And you can see that. It's like a slope going downhill. Let's look at another one of these. These are not bad. If you just want to plug and chug the points, that is fine. These are generally multiple choice questions. Y equals 1/6 x minus 3. All right, let's take a look at this one. First of all, we're going to be doing this for negative 3 to positive 3. So negative 3, let's put my x here, my y here. So negative 3, positive, negative 2, negative 1, 0, 1, 2, and 3. Oops, I just messed that up. All right, so if I put in a negative 3, negative 1/6 times negative 3 is negative 3/6 minus 3, which ends up being negative 1/2 minus 3. Just ends up being negative 3.5. So for a x of negative 3, it gives me a y of negative 3.5, so it's going to be about right there. These are hard to show on there, aren't they? Negative 2, so if I plug in a negative 2, it'll be 1/6 times negative 2, which is negative 2/6, or negative 1/3 minus 3, which again will be negative 3 1/3. So I'll go here, it's going to be about right there. For negative 1, I'm going to get negative 1/6 minus 3, which is going to be right there. Trying to hit that right. For 0, 0 times x, or 0 times 1/6 is 0. Minus 3 gives me a negative 3 right there. And then if you do the rest of these, are going to go on up. Here's going to be my line. The key thing that I'm going to give you all the values here, but the key thing I want you to see is that number 1, it has a positive slope. The slope is 1/6. The y-intercept is negative 3. It's going to go through the y-axis at negative 3, and you see that it does. But for negative 3, I got what? Negative 3.5. For negative 2, I got negative 3 1/3. For negative 1, I got negative 3 and 1/6. For 0, I got -3. For 1, I got -2 and 5/6. For +2, I got -2 and 2/3. And for +3, 1/6 times 3 is 3/6, which is a half. A half minus 3 is -2 1/2. But what I would get in the habit of doing, let me show you this. It says right here, if I just look at the equation, I'm going to draw this. Here, look at this. It goes through at -3, so I know where y is -3. That's where it's going through. My slope is 1/6. So I go up 1/6. There will be another point. You just need a general idea of where that line is going through. Don't worry too much about the plugging in the values. Worry more about getting that equation through the graph correctly. All right, let's look. Let's see what the next one is. Evaluating functions. Remember what I told you about these? These are just plug and chug type problems. Evaluate the function f of x equals 3x plus 7. First for f of 2, so f of 2 would equal 3 times 2 plus 7, which equals 6 plus 7, which equals 13. These are just plug and chug. Now evaluate that function for f of -3. F of -3 equals, so 3 times -3 plus 7 gives me 3 times -3 is -9 plus 7. -9 plus 7 equals -2. So I evaluated them. F of -3 is 13. I'm sorry, f of 2 is 13. F of -3 is -2. Let's see if I've got another one of these to work. Yeah. Here's one that's squared. Oh no. Not a problem. First of all, evaluate that for f of 0. F of 0 equals, that's a stray sign there, equals 2, we'll make that a 2, times 0 squared. I'm betting you will see one like this with a square on it, minus 3. Well, 0 squared is 0, so 2 times 0 is 0. 0 minus 3 equals -3. So f of 0 is -3. Let's look at f of 5. F of 5 equals 2 times 5 squared minus 3. Remember now, PEMDAS, parentheses, exponents, multiplication and division at the same time, addition and subtraction at the same time. So first of all, I square my 5. 2 times 5 squared. 5 squared is 25. 2 times 25 minus 3. 2 times 25 is 50 minus 3 equals 47. So f of 5 is 47. Finally, let's do f of -3. Just going to plug and chug here. 2 times -3 squared minus 3 equals -3 squared. -3 times -3 is a positive 9. Minus 3. 2 times 9 is 18. 18 minus 3 is going to give us 15. So f of -3 is 15. Remember, this is just a machine. Functions are machines. You are dropping a value into that function and seeing what it spits out. That's all we're doing there. I think I'm going to stop here and create another video so that these don't get too long. They take a while to upload. So I'm going to stop this one, and we are going to start another one, and you'll have a separate link for it.